California has wet years and dry years. We have droughts, we have floods. The last 3 years now have been a drought for California. I would argue it was a drought before the governor made an official declaration. But the official declaration of drought does a number of things. One thing it does is it causes people to pay more attention. It calls attention to the nature of the problem, the severity of the problem, the need to take some action. In this case, the governor also offered some financial assistance to be made available to people suffering severe economic impacts of the drought.
We use water in a variety of ways in California. About 80% of the developed water supply, that's the supply that humans use, about 80% of that is for agriculture. They're a major user. The remaining 20% is for cities. That's water we're using in our urban areas, both indoors and outdoors, in our homes, in our businesses, and also in our schools. In a drought, there are many restrictions that come into play, either mandatory or just simply because the water isn't there and we can't use it. So typically our water use is lower during droughts. That's because we're not watering our landscapes as much. Agriculture in some cases may be forced to fallow. Agriculture has done a lot though. They are using water more efficiently than they were 10 and 15 years ago, but there's more they can be doing and more they'll have to be doing because of the drought.
At the individual level, we can wash our clothes with efficient washing machines rather than inefficient washing machines. We can flush our toilets with the smart new high-efficiency toilets. There are also behavioral things that we can do. We can change our behavior in the short run, and we do. We let our lawns go brown, or we don't wash our car as often or at all. And those voluntary short-term measures can be very effective. There are two major things we can do. One is cut our demand and become more efficient. The other is look at alternative sources of supply.
There are potential to capture stormwater, to then use that water and recharge our groundwater aquifers. We could be doing more rainwater harvesting or using rainwater cisterns to, again, capture stormwater so that we can use it when we have a drought. We can also be looking at recycled water. There's a lot of opportunity to take water that's been used, to treat it again, and then to use it again to recharge aquifers, to use it for landscaping, to use it for industrial processes. And so there's significant opportunity there as well.
In the long run, we could look at desalination. There's a lot of ocean water out there, but it's an extremely expensive source of new water. I think we'll see more and more desalination over the years, but we should do the things that make economic sense first. But the truth is, even in a wet year, even in a normal year or a wet year, we don't have as much water as we would like. And so some of these things that we have to do for a drought, we really ought to be doing full time. We ought to be doing in a permanent way.
If you look back over time, all of your extreme events in California are caused by atmospheric rivers.
An atmospheric river is a corridor of water vapor that on Earth they are formed in the tropics and they're carried in these narrow streams thousands of miles, and then they eventually hit land. And when they hit land and they encounter mountain chains, you get large amounts of precipitation. It actually turns out it's kind of an escape valve of all this energy and water vapor that's formed in the tropics that is carried poleward.
On average, in California, you'll see 5 to 7 atmospheric rivers during the winter season.
30 to 50% of our water resources come from these atmospheric river storms.
Not all atmospheric rivers create floods, but if you look back historically to the floods in California, most of the floods that do occur are caused by atmospheric rivers.
The history of atmospheric river storms goes back about a couple thousand years. We have records of huge floods that occurred on average every 1 to 2 centuries, that we have strong evidence that those are formed from atmospheric rivers. The largest flood that we've had in California was in 1861, 1862, that winter. And although most people don't know about it, it inundated huge areas of the state. The Central Valley, 300 miles long, 20 or 50 miles wide, was under at least 10 feet of water. It was such a disaster that the state went bankrupt, and thousands of lives were probably taken. We haven't had anything like that since.
We're in the town of Bodega Bay, installing what's called an atmospheric river observatory. It's a collection of high-tech instruments that are really designed to probe the atmosphere and figure out what's causing the extreme events. We use the instruments to tell us what's going on with the winds and the water vapor transport. And there'll be 4 of these installed along the California coast. Monitoring the conditions continuously year-round will also give us a hint on how climate is affecting weather in California.
We haven't had a major atmospheric river storm since 1861. We haven't had a major drought. I mean, the longest drought we've had has been 6 years. And yet we've seen that in the past, droughts can last for decades, if not over a century. It's important to understand our climate history and to understand where our water comes from and how we should really be preparing now for a drier world, but also a world that may have bigger floods.
Ocean acidification is a phenomenon that we're experiencing now due to the fact that the ocean is absorbing, like a sponge, carbon dioxide that we produce.
As CO2 is absorbed by the ocean, it changes the chemistry, which can cause the oceans to become more acidic.
We know that ocean pH is changing, and that in itself is alarming.
You can acidify any liquid just by taking a straw and blowing through it into a glass of water. And the CO2 in your breath is introduced into the water and causes a dropping of the pH in the water. Same thing is happening in the ocean. In the last 250 years or so, the acid levels in the ocean have increased 25 to 30%. And this is directly measurable. You can go out into the ocean with special meters and you can measure that increase in acidification.
As you increase the concentration of carbon dioxide in the water, you're actually going to affect ocean organisms physiologically and affect their metabolism. It's like they're breathing into a brown paper bag.
You lose some of the species you would expect to be really sensitive, and these are species with shells.
Many organisms in the ocean build skeletons out of calcium carbonate, which is basically chalk. Clams, corals, snails, many organisms use this material for their skeletons. Ocean acidification, it will literally dissolve some of the shell. It will affect the structural integrity of the shell. And this is a skeleton of the animal. Think of your own skeletons basically becoming a little bit rubbery.
Oysters are ecologically important. They filter water, they provide habitat for a lot of other organisms at the base of the food chain.
We're beginning to see effects in microscopic planktonic organisms in the Southern Ocean, and that's alarming because some of these microplankton are responsible for producing much of the food at the base of the food chain.
We are all connected.
We depend on the ocean for our economies. Out here on the West Coast, for example, one of the areas of concern is oyster farming.
We can already see how economies are being affected. We've had a response to the $300 million potential loss of a huge economy through the oyster fishery in the state of Washington. There's actually been a response on the part of the government recognizing explicitly that this is going to be an issue. It's going to be an enormous impact on coastal communities and in the way that a lot of people make their living.
I think other states will follow. I think California should be paying attention to this.
The number one thing that we can do to combat ocean acidification is to stop burning fossil fuels. Burning fossil fuels has been one giant chemistry experiment threatening the oceans that give us life. We can turn toward clean and renewable energy sources, and if we can tell our friends and our elected officials about ocean acidification, we can leave those chemistry experiments in the classroom and start being part of the solution. The oceans don't have a voice, so if we can use our voices in the classroom, in our offices, on social media, at the dinner table, we can educate people, we can inspire people, and we can ultimately be leaders for the ocean.
An earthquake is really a rupture or a break of the rocks that happens suddenly. The stress builds up over years, decades, even hundreds of years, but the earthquake happens all of a sudden. Why? Why on that particular day?
Harold Tobin aims to find out as he and his colleagues drill deep into the ocean floor off the southwestern coast of Japan.
The biggest faults in the world are the ones that make the magnitude 9 earthquakes and the tsunamis, and they're all offshore. They're all underneath deep water in the ocean. We'd like to actually get inside the fault zones themselves, deep beneath the surface, in order to learn about the properties of the rocks and what the stresses are and what's building up as strain. So the only way to do that is actually to use a drill, just like sort of the oil drilling field, but using it for science instead of for drilling oil wells, to get down into those faults even kilometers below the surface. We're drilling holes as deep as 4 miles, 7 kilometers below the surface, in order to get at those fault zones, because we have to get to where the earthquakes occur, and they occur really deeply. We drill down and we can take core samples, so we can take rock samples, sort of meter by meter as we go along, and look at what that core tells us about the geology. We can also put instruments down in those holes so that we can measure things we'd like to know, very small earthquakes using special seismometers that go in the borehole, or strain of the rock, or maybe the temperature of the rock at those depths, and monitor that over time to look at how it changes in those faults between earthquakes and maybe leading up to the next big earthquake.
In 2006, the team started drilling in the Nankai Trough, a region that has experienced a large earthquake and tsunami about every 100 years. The team has already come up with big surprises.
One big kind of surprise that's revolutionizing the way we're thinking about these faults a little bit is we drilled into the fault actually at a quite shallow position, just sort of a few hundred feet below the surface, and found really good evidence that the earthquake slip had come all the way to near the surface at the seafloor there. That tells us that when one of these deep earthquakes starts, it can rip through the rocks right up to the seabed, and that's really what makes the tsunami potentially so damaging, is when it moves the seabed a lot. So it's really changing the way we look at how these faults go when a big earthquake occurs.
Tobin also runs a geoscience visualization lab at the University of Wisconsin-Madison that creates 3D models of the drilling locations.
There's also a very practical goal, is once the beginnings of an earthquake rupture start to happen, how quickly can an early warning be formulated? And how quickly can we estimate that it's not a little earthquake, it's really a big one that's starting, and over just seconds determine that a warning needs to go out to, say, nearby populations. And so wiring up this fault zone off the coast of Japan is one way of getting at that problem, and then getting the data back real time, onto the internet through these seafloor observatories, so that those kind of warnings can go out.
Warnings that might save lives on the particular day when an earthquake strikes. We can never know exactly when the next big one will occur, but the work of Tobin's team can help us determine the likelihood and timing of these events.
We San Franciscans live in a pretty urban environment, but our city is also very green, and red, and yellow, and purple. The city is quickly filling with gardens, tightly squeezed into the most unusual spaces.
We're on the roof of Blythe Memorial Church in the Tenderloin in San Francisco. This idea has been floating around that we could use this roof space on all these buildings in San Francisco in order to plant these gardens. And so this was a demonstration of that it's possible. The food that's grown in this garden on the roof goes back down to the basement. The soup kitchen cooks lunch and dinner every day.
We are at the Life Learning Academy Charter School Garden here on Treasure Island. We have over 25 raised beds, probably about 15 fruit trees, and 50 perennials in the ground. And it's a wonderful garden where teens work in the garden and produce food, both for them to take home and to eat in the school during lunch.
Garden for the Environment is San Francisco's teaching garden. It's been here for 20 years. We want San Franciscans to get their hands dirty.
San Francisco recently passed a new ordinance that changes the zoning laws here in the city. And what it does is two things. It makes clear that gardens are welcome in all parts of the city. So no matter where you are, what kind of zone, whether it's industrial, commercial, residential, gardens are now welcome throughout the city so long as they're less than 1 acre in size. And the second thing it does, which is the more forward-thinking aspect, is gardeners are allowed to sell what they grow, no matter where they grow it, which is a change. Urban agriculture also encompasses animal husbandry, so raising animals, chickens, some people have goats, bees is another popular aspect of urban agriculture.
The new ordinance appears to be working to the benefit of all city residents.
You get less runoff of the water, so you get less of the pollutants in the streets going into our local oceans. And then you also, just having more of this carbon sequestration through the plants is what you're getting as a result.
We're growing food organically, meaning we're not using harmful chemicals.
It is often said that the average food miles of a single American meal travel 1,500 miles from farm to table. Well, if you can make that 1,500 inches from your backyard to your dinner table, it's a big difference in the amount of fuel that was used in the distribution of that food.
Not only is urban farming greening the city, it's teaching life lessons as well.
It gets young people, especially, involved in growing food and being connected more with their food, which means they're more apt to make healthy choices when they're ordering food or cooking it themselves.
The benefits of growing food at home are that you have a relationship with what appears on your meal. When it takes us 180 days to bring a carrot from the garden into the table, when we battle with slugs and snails, and then we see what we can grow, we have that much deeper of an appreciation for the food that we buy at the grocery store and the hard work that farmers are doing to bring us that delicious food.
So find a bit of soil, grab a hoe, plant some seeds, and you just might sow some hope for a
About 1.5 billion people on Earth depend on the sea for their primary source of protein. I'm not going to go to those people and tell them to stop eating fish. But I do believe that we as consumers have the responsibility to confront the footprint that our consumer habits are having on our planet. And when it comes to looking at seafood and fish, a lot of the things that we eat and are used to eating are really doing terrible damage to the earth and to the ocean.
As a consumer buying seafood, decisions can be difficult. What's sustainable? What's not? We decided to go to the experts. Greenpeace has been working on sustainable seafood since the 1970s, and the Monterey Bay Aquarium has distributed 40 million of their Seafood Watch cards over the past 12 years.
We try to spend most of our energy not in direct consumer education, talking to people about good fish, bad fish, better fish, but doing that kind of interaction with someone that doesn't buy a pound of fish a week, that buys 100,000 pounds of fish a week.
Targeting the major suppliers of seafood seems to be working.
The biggest change we've seen just over the past few years is major retailers and food service and restaurateurs making changes and sustainable seafood commitments in their areas. It's become part of their overarching corporate sustainability initiative, and it's tremendous because they've made commitments to source from environmentally responsible fisheries and fish farming operations.
Seafood became a focus for the company about, I'd say, 5 or 6 years ago. It took some time and some study and some understanding to build our awareness and to get a better idea of the right path to take and the things that we should be doing. We first have to identify where sourcing of sustainable species and sustainable fisheries, fisheries that might be undergoing improvements. That's taken some time.
The 2011 Guarding Away the Oceans rankings resulted in Safeway taking the top spot out of the 20 retailers that were analyzed. And a lot of people found this really surprising. I ran Safeway through the methodology 3 different times to make sure that those numbers were right.
We don't practice our programs to please Greenpeace. We do it for ourselves and for our customers. Getting a #1 rating from Greenpeace is very nice, and we really appreciate that. We recognize we have a long ways to go also.
Am I surprised? I guess not really. But I also think that they're not done. I think that we're going to see some more impressive stuff from them.
Safeway may have a long way to go, but so do individual consumers. We need to ask the right questions.
Just ask, is it farmed or wild, and where is it from? And then you could use your app on your iPhone or your Droid, or you could use your Seafood Watch Pocket Guide to figure out if it's sustainable or not. But do ask questions, because even if you don't get an answer that you're looking for, at least you're sending a message to the business that this is important to us as a consumer, and you'll be surprised how many of these businesses are responding.
Right now, our appetite for seafood is harming the planet. But we can use that appetite to make the planet healthier too, if we know how to use the tool.
Sea level rise is not exactly breaking news.
Sea level is rising primarily because of global warming. Global warming is warming the water, and warmer water, like most liquids, occupies larger volume than a colder liquid. So as the oceans warm, they expand and sea level goes up. But more significantly, as air temperatures rise, we begin to melt those polar ice caps, the Greenland ice sheet, alpine glaciers. There's more water entering the ocean, so sea level rises. So the global average sea level has been going up, but that varies from place to place.
In the past few decades, sea levels have actually been falling in the San Francisco Bay, but that's about to change.
Besides this large-scale global warming, we have a shorter term PDO, or Pacific Decadal Oscillation, here in the North Pacific, that affects the way that bodies of cold water move back and forth between the East and the West Pacific. And we've been in a phase for several decades now where the temperature of the water being lower in the East Pacific, and that's our side of the Pacific, causes our sea level to be lower off the coast of North America, whereas it's higher on the other side of the Pacific. But now the oscillation means this goes back and forth. The oscillation swinging the other way.
What's a little sea level rise? Well, experts say that levels could rise as much as 14 inches by 2050. That could mean bad news for low-lying areas around the bay, wetlands, islands such as Alameda, and more.
Look at where our airports, two major airports, are located in Oakland, San Francisco. Over the next few decades, we'll see some of those land masses essentially becoming submerged.
Many officials would like to see restrictions on developing low-lying areas around the bay, but decisions have yet to be made. Understanding complex climate patterns will help us plan for the future.
About a year ago, the Deepwater Horizon drilling rig exploded and sent oil gushing into the Gulf of Mexico. Over the course of the next 3 months, almost 206 million gallons of crude oil spilled into the Gulf until the well was finally capped. At the time of the leak, 3 local scientists did what they could to get involved in the disaster.
I just decided to really just jump in and go and see how I could help. Really in any way.
The sea turtles that Jay studies were heavily impacted by the oil in the Gulf.
I originally thought that I was going to be on boats, reaching into the water and plucking turtles out of oil. And what I ended up doing was something kind of different. I got on an airplane and we flew aerial surveys, and I got to survey the whole spill area to look for wildlife, to look for sea turtles and other animals, and to report that back. I immediately got really a bird's eye view of what was going on and access in a way that I really hadn't expected. And so I of course had my video camera along, and I collected a lot of footage that I shared. Lots of people at CNN gobbled it up because they didn't have access.
Thomas Aswell found himself at the Gulf without a plan as well.
When I heard that there was a spill there, and it was a spill that was significant, I felt an obligation to try to do something. And so I got involved with a group that is based out of UC Berkeley. It was a study group called the Deepwater Horizon Study Group that was advising the National Commission on their investigation of the spill.
Thomas and Jay took a big picture approach to inform decision makers, while Peter Ruknarayan and his colleagues took a decidedly more narrow view.
We started working on the oil spill within 2 weeks of its occurrence last year. We were interested to know if we could detect elements from crude oil in the shells of molluscan animals, so clams, snails, and so on.
It turns out you can read these animals' shells like tree rings. And Peter knew from previous work that crude oil can leave its marks in the shell in the form of hydrocarbons.
So what we need to do is to ensure that any signal we detect in the shells that we've been collecting since May last year can actually be attributed to Deepwater Horizon and is not sort of natural levels of contamination that are in the bay.
A year later, the work continues for all three researchers.
We detected the presence of vanadium and lead in shells collected in August. We're fairly certain that the vanadium is a Deepwater Horizon signal.
While Peter and his colleagues continue to test the shells, Thomas returns often to the Gulf.
There's still oil sitting at the bottom of the Gulf. There's research at the University of Georgia that's finding this in very deep water, and I see this in very shallow water.
Thomas is currently working with agencies to hopefully remove remaining oil, and he's also looking toward potential future spills, learning from mistakes made here.
And now that I've finished my report to the Obama administration, really looking at what's going to happen going forward, the information that I gathered from the cleanup effort and the response, and putting together some new regulation so that we incorporate better technologies and a better response so that it's more focused on containing and recovering the oil from the environment and minimizing that impact.
The future of the world's oceans, boy, if you had asked me when I first started studying them, I would have thought limitless. It can only get better. New technologies were being developed. Scuba diving was in its infancy. It was such an exciting time. Now that we've developed all these technologies, now that we have plundered the oceans so exhaustively, I can't predict what will be left for the next generation.
I'm fearful for the future of the oceans.
It's a time for great concern.
I think the future for the oceans overall is a fairly grim one because we're not taking care of the oceans.
We don't know what the future of the ocean is, but it's pretty scary and pretty ominous.
There are so many different assaults that humans cause in the oceans. With overfishing,
pollution,
runoff from the land,
movement of exotic species,
oil spills, dredging,
ocean circulation disruption,
overexploitation of species,
habitat destruction,
coral bleaching.
Climate change is going to have profound impacts on the ocean marine life, and we just don't know how bad it's going to be, but it's probably the most serious issue that we face.
I'm not hopeful about the future of the oceans, but I'm optimistic that with the next generation of children that visit this museum, children that visit the ocean, children that read, children that care, they won't let us get away with what we've been doing for the last 2 generations.
I'm choosing to believe the future of the oceans is all good. I want to believe that the problems are not insurmountable, that we can come together and figure out a way to deal with them and stick to it. And in a large extent, I have to think that way because I have a 7-year-old daughter and I want her to have the oceans.
The future of our oceans is certainly in our hands, and really now is the time to decide what we want the future of the oceans to be.
It's not too late. No matter who you are or where you're living, you have the ability to make that change.
We've never had more information about how to improve the oceans, about how to solve some of these problems. It's a challenging time, but it's an exciting time.
We can all help if we do just a little bit, and altogether they'll add up and make a big impact.
I have to trust that there are people around the world just like me doing the best that they can to engage and educate people in their communities about the ocean's health.
And I can grab and shake people and say, look, pay attention. It doesn't have to be this way.
So there is that hopefulness that I try to carry and keep in my heart.
It's worth saving.